In the 1980s, the Hubble telescope gave us a view into space, our first real big view into space.
This is the very first telescope we placed in space, obsoleting the land telescopes like the Maui Observatory, the Arecibo Observatory in Puerto Rico, the FAS telescope in China, the EL telescope in Chile, and all others.
So did you know I had several opportunities to spend time with Bob Chandler, or Dr. Bob as we used to like to call him, who was the original chief scientist for the Hubble telescope and actually the chief project manager as well. We saw pictures from the Hubble last year during Town Hall number 93. Now, we want to give you a pictorial space update. So over to Sarah with Art Talk 144, a 2023 view from Hubble in the midst of the final frontier.
Good morning, everyone. Pardon my voice today. I'm a little bit under the weather, but yes, today we are revisiting, excuse me, a topic that we covered last year. Launched into space in 1990, the Hubble Space Telescope is always capturing new images of deep space that increase our understanding of our universe. And today we'll focus on the images that it has captured in 2023 thus far. The barred spiral galaxy UGC 678 takes center stage in this image from the NASA ESA Hubble Space Telescope. The spectacular galaxy lies around 260 million light years from Earth in the constellation Pisces and is almost face on, allowing its winding spiral arms to stretch across this image. Just like humans, stars have a natural life cycle. They're born, grow up, and eventually grow old and die. Studying this stellar life cycle is an important topic for astronomers. The ends of stars' lives can be marked by truly spectacular events, including titanic supernova explosions, the creation of dense neutron stars, and even the birth of black holes. UGC 678 was recently found to be host to one of these events. In 2020, a robotic telescope scanning the night sky in search of dangerous asteroids discovered evidence of an enormous supernova explosion in the galaxy. Here we can see JO204, a jellyfish galaxy, named that because of the bright tendrils of gas that appear in this image to be drifting below its bright central bulk. The galaxy lies almost 600 million light years away in the constellation Sextans. This image is the third of a series of pictures of the week from the telescope featuring jellyfish galaxies. This series of images is possible thanks to observations made of 6 of these jellyfish galaxies to better understand star formation under extreme conditions. Given the kind of dreamy appearance of this image, it would be understandable to wonder why jellyfish galaxies would be the epicenters of star formation. While the delicate ribbons of gas beneath JO204 may look like floating jellyfish tentacles, they're in fact the outcome of an intense astronomical process known as ram pressure stripping. Ram pressure is a particular type of pressure exerted on a body when it moves relative to a fluid. For example, is the sensation of pressure when you experience that your body experiences when you're standing in an intense gust of wind. The wind is the moving fluid, and your body feels pressure from it. An extension of this analogy is that your body will remain whole and coherent, but the more loosely bound things like your hair and your clothes will flap in the wind. The same is true for jellyfish galaxies. They experience ram pressure because of their movement against the intergalactic medium. The galaxies experience intense pressure from that movement, and as a result, their more loosely bound gas is stripped away. This gas is mostly the colder and denser gas in the galaxy, which when stirred and compressed by the ram pressure, collapses and forms new stars in the jellyfish's tendrils. UGC 2890 appears side-on in this image. This galaxy lies around 30 million light years away in the constellation Camelopardalis. In 2009, astronomers spotted a catastrophically powerful supernova explosion inside this galaxy. While the supernova itself has long since faded from view, Hubble recently took a break from its regular observing schedule to inspect the aftermath of this explosive event. A Type II supernova is an energetic explosion that marks the violent death of a massive star. As it runs out of the elements necessary to fuel nuclear fusion, the core of a massive star flickers out and stops producing energy. With nothing to support the crushing force of gravity, the core of the star shrinks and then suddenly implodes, leaving the star's outer layers to collapse inwards and rebound out into space as a supernova explosion. This observation is one of Hubble's many investigations of Type II supernovae. Astronomers turn to Hubble's advanced camera for surveys to explore the surroundings of Type II supernova in the hope of discovering the ages and masses of the stars in that neighborhood. This would reveal insights into the types of stars that eventually create a Type II supernovae, as well as revealing any stellar survivors of colossal supernova explosions. This picture of the week shows Z22915, a celestial object that lies about 390 million light years from Earth in the constellation Lyra. Z22915 is defined as several different things. Sometimes it's an active galactic nucleus, an AGN, sometimes as a quasar, and sometimes as a Seyfert galaxy. But the answer is that it's kind of all of these things at once because those three definitions overlap a lot. Quasars are a particular type of AGN. They're typically both extremely bright and extremely distant from Earth. Several 100 million light years is considered nearby for a quasar, making Z22915 relatively local. Often an AGN is so bright that the rest of the galaxy cannot be seen, but Seyfert galaxies are active galaxies that host very bright AGNs while the rest of the galaxy is still observable. The Tarantula Nebula is a large star-forming region of ionized hydrogen gas that lies 161,000 light years from Earth in the Large Magellanic Cloud. And its turbulent clouds of gas and dust can be seen swirling between the region's bright, newly formed stars. The Tarantula Nebula is a familiar sight for Hubble. It's the brightest star-forming region in our galactic neighborhood and home to the hottest, most massive stars that we know of. This makes it a perfect natural laboratory in which to test out theories of star formation and evolution, and a variety of Hubble images of this region have been released to the public in recent years. The telescope also recently delved closer into this region, revealing thousands of never-before-seen young stars. This new image combines data from two different observations. The first was designed to explore the properties of the dust grains that exist in the void between stars, and which make up the dark clouds winding through this image. This observation complements another Hubble observing proposal that reveals how interstellar dust interacts with starlight in a variety of environments. The bright variable star V372 Orionis takes center stage in this image, which has also captured a smaller companion star in the upper left of this image. Both stars lie on the Orion Nebula, a colossal region of star formation, roughly 1,450 light years from Earth. V372 Orionis is a particular type of variable star known as an Orion variable. These young stars experience some alterations and growing pains, which are visible to astronomers as irregular variations in luminosity. This image overlays data from two Hubble instruments, the Advanced Camera for Surveys and Wide Field Camera 3, and they show both infrared and visible wavelengths and are layered to reveal different details of the Orion Nebula. Hubble also left its own subtle signature on this astronomical portrait in the form of the diffraction spikes surrounding the bright stars. The four spikes surrounding the stars in this image are created by four vanes inside Hubble, supporting the telescope's secondary mirror. This globular cluster lies less than 50,000 light years from Earth in the Ophiuchus constellation. NGC 6355 is a galactic globular cluster that resides in our Milky Way galaxy's inner regions. Globular clusters are stable, tightly bound clusters of tens of thousands to millions of stars and can be found in all types of galaxies. Their dense populations of stars and mutual gravitational attraction give these clusters a roughly spherical shape with a bright concentration of stars surrounded by an increasingly sparse sprinkling of stars. The dense bright core of NGC 6355 was picked out in crystal clear detail by Hubble in this image and is the crowded area of stars towards the center. The planet Saturn is easily recognizable for its ring system that can be easily seen through even a small telescope. But astronomers have now found that the rings are not as calm as they look. A rain of icy particles is affecting the giant planet's weather. It took observations from the Hubble Space Telescope, as well as the retired Cassini probe and the Voyager 1 and 2 spacecraft, as well as the retired International Ultraviolet Explorer mission to pull it all together. The telltale evidence is an excess of ultraviolet radiation seen as the spectral line of hot hydrogen in Saturn's atmosphere. The most feasible explanation is heating caused by icy ring particles raining down onto Saturn's atmosphere. This rain could be due to the impact of micrometeorites, solar wind particle bombardment, solar ultraviolet radiation, or electromagnetic forces picking up electrically charged dust. The Orion Nebula is home to tens of areas that could be burgeoning planetary systems. Researchers have identified two different types of disks around young and forming stars, those that lie close to the brightest star in the cluster and those farther away from it. This bright star heats up the gases in nearby disks, causing them to shine brightly. The disks that are further away do not receive enough of the energetic radiation from the star to set the gas ablaze. Thus, they can only be detected as kind of dark silhouettes against the background of the bright nebula, as the dust that surrounds these disks absorbs the background visible light. In these silhouetted disks, astronomers are better able to study the properties of dust grains that are thought to bind together and ultimately form planets such as our own. In the picture on the left, the forecast for Jupiter is for stormy weather at northern latitudes. A prominent string of alternating storms is visible, forming a quote-unquote vortex street, as some astronomers call it. This is a wave pattern of nested cyclones and anticyclones locked together like the alternating gears of a machine moving clockwise and counterclockwise. If these storms get close enough to each other and merge together, they could actually build an even larger storm, potentially rivaling the current size of the Great Red Spot. On the right, of course, the legendary Great Red Spot takes center stage. And though its vortex is big enough to swallow Earth, it's actually shrunk to the smallest size it's ever been, according to observation records dating back 150 years. Jupiter's icy moon, Ganymede, can be seen transiting the planet on the lower right. Slightly larger than the planet Mercury, Ganymede is the largest moon in the solar system. Every year, NASA and ESA learn from and study images from the Hubble Space Telescope, and there's so much we still don't know about the universe, but it's with these images that astronomers can continue to discover and learn about deep space. Thank you.
The show must go on, and I want to thank you for your professionalism and powering through this art talk and making that possible. The images that you just showed and the discussion was just amazing. Patty, what did you think?
I loved all the photos, but my favorite was the Orion Nebula.
You know, I can't wait to see what the Hubble sends back next in the next couple of months.